You have an array of numbers, but most are just noise, repeated again and again. Your mission is to find the single largest value that stands completely alone. If every number has a twin, you return nothing. Can you spot the biggest loner in the crowd without checking every single pair? Given an integer array, return the largest number that appears exactly once. If no such number exists, return -1. The challenge is filtering out duplicates efficiently. You need to distinguish between numbers that show up multiple times and those that appear only a single time, then pick the maximum from that unique set. The naive approach checks every number against every other number to count its occurrences. For each element, you scan the entire array again. This leads to quadratic time complexity, O of n squared. As the input grows, the redundant comparisons explode. You're doing the same counting work repeatedly, which is unsustainable for large datasets. The key insight is to stop counting on the fly and count everything first. Use a HashMap to store the frequency of every number in a single pass. Iterate through the array once, updating the count for each value. Once you have the full frequency map, iterate through the map itself. Check which keys have a value of exactly 1. Track the maximum key among those unique entries. This separates the counting phase from the selection phase, eliminating redundant scans. Let's trace this on our example. First, we build the frequency map. 5 appears once, 7 once, 3 twice, 9 twice, 4 once, 8 once, and 1 once. The map now holds the counts for every distinct number. Next, we iterate through this map. We ignore 3 and 9 because their counts are 2. We look at 5, 7, 4, 8, and 1. All have a count of 1. We compare them to find the largest. 8 is greater than the others, so it becomes our candidate. The answer is 8. It is the largest value in the array that appears exactly once. All larger numbers like 9 were disqualified because they appeared multiple times. You'll spot this pattern whenever you need to find unique elements, most frequent items, or check for duplicates. The signal is always count occurrences before making a decision. If the problem asks about frequency or uniqueness, a hash map is almost always the optimal path forward. Time complexity is linear, O of n, since we traverse the array and the map once. Space complexity is also O of n to store the frequency counts. Try the next problem using the same frequency map pattern. Subscribe for more intermediate DSA deep dives.